Welcome back to another fun and exciting episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
I'm your host for this episode, Heidi Campo, and joining us today is Professor Fred Watson, astronomer at large. Fred, how are you doing today? You've been quite busy.
Yeah, I've been traveling a little bit, just down to the nation's capital, the city of Canberra, which is about 3.5-hour drive from here on a road that's really pretty good because it's a sort of dual carriageway all the way, so you don't have to worry about not being able to pass heavy trucks and things. But it had the drive down on Sunday evening had a little bit of astronomical interest because as I was getting near Canberra, which is down to the south of us, and approaching the state of Victoria, which is still quite a long way away, but never mind, that's where I was approaching, I saw a fireball. A bright meteor, very bright meteor. It was right in my field of vision, so the car must have been pointing kind of southwest. This thing was probably 15, 20 degrees above the horizon. Came in very bright green fireball, green coming from partly the atmospheric oxygen, partly from the iron in the object. And sort of, I guess it lasted for maybe 0.9 of a second, something like that. And then at the end just disappeared in an orange dot. But the next morning, the media were full of this meteor that had been seen in Victoria, the state of Victoria, which was probably a good 300 kilometers from where I was. And some people said they heard the sonic boom that went with it. So there's a big media blitz yesterday. I got a call from one of the radio stations to talk about it yesterday afternoon, actually on the drive back. So yeah, a really exciting thing. I've seen, being an astronomer and used to work at night, I've seen a lot of those. Well, by a lot, maybe a dozen throughout my working life, where you see something bright enough to light up the landscape. But it's quite a long time since I've seen one, so it's good to reconnect with the world of immediate astronomy, where the Earth is ploughing up bits of dust and debris through the atmosphere.
Well, and when you do see them, it's such an amazing experience. I remember I've seen a few of them in my lifetime. I think just 3, but the one really brilliant one that I remember. I want to ask you if my memory has inserted this sound into it, or if this is possible. But it was so bright and it was sparkling, like magical, like some animator had put sparkles in the sky.
Okay.
And it's just sparkling and glitzing across the sky. And I can swear in my memory, I hear like almost like the firecracker sound, or like the sound like a sparkler makes as it's going across the sky. But I'm like, man, is my memory just inserting that sound because that's what it looked like? Or did it really make that sound?
So the issue with these things, if that was a meteor, and it sounds as though it was, and a fireball is a bright meteor, there is a definition, I can't remember what it is, as to how bright it has to become to be called a fireball. Well, did you see any colour in it, in the crackles? Could you see any colours, or sorry, in the
I remember
sparkles?
Pops. The biggest memory I have is the pops of colour.
Yeah,
like
okay.
just like a sparkler.
Yeah. The thing is that where they hit the atmosphere is about 90 kilometers, 60 miles up in the air. And so it's too far away to technically to hear the sound it makes as it's exploding. But the fact that it is moving so fast through the atmosphere means that you sometimes do get a sonic boom. Which is the bang, and it's a single bang rather than a set of pops. But that can be up to 90 seconds after you've seen the visual thing, because it takes that long for the sound wave to propagate down through the atmosphere from that height. So it may well be that you were hearing something else, or it was perhaps inserted by your brain, as you suggested. Usually the sonic boom will be after. Any noise will be after the event.
Well, that's good. That's good education. It's good to always have you as our reference to ask us. And speaking of bright stars in the sky, we lost a big one. And that's our first story today, Jim Lovell.
Yeah, a veteran astronaut, a name that for me, you know, in the early years of the space age, following every move with intense scrutiny. It's a name that's very familiar. Jim Lovell, the commander of, not sure whether he was the commander. He was commander of Apollo 13, but his earlier mission was Apollo 8. He was on the classic Apollo 8 mission, which we talked about a couple of episodes ago with the Earthrise crater, Apollo 8, 1968. So he was, as I said, the commander of Apollo 13. I think it was his voice that uttered those immortal words, "Houston, we have a problem," when the fuel cell exploded in the service module of Apollo 13. So very, very famous figure. His supreme ability to cope with disaster, I think, was a big contributor into the success of Apollo 13. The fact that the mission, whilst they didn't touch down on the moon, I think everybody knows the story. The fuel cell exploded on the way out to the moon. They just did a translunar orbit, came back, and essentially did a direct re-entry of the command module and landed safely and were picked up. An extraordinary story. The movie is well worth watching, Apollo 13. It's pretty accurate, fairly close to the truth. But yeah, I think a lot of the success of that was just the cool head of this astonishing astronaut, who I think retired from the astronaut corps not that long afterwards and went into business, I think. So a very, very well-known name at the time, and basically somebody who we've now lost a link with those early years of the space adventures, human spaceflight. He was 97 when he died a week or so ago.
Yeah. And, and I think, I don't really know what his lifestyle or health was like, but I do know that those personality types, those people who are able to stay calm under pressure and manage their stress, it really does wonders for your health. And the fact that he made it to 97, I think, is a little bit of a testament to that. So
that's right.
So these are people that we need to remember. They're not just role models in space, but they're role models for like how to kind of live our life and conduct ourselves here on Earth. I think it's a little bit cheesy, but it's like, you think of astronauts as just kind of like these larger than life superstars in so many ways. And it's like, they are the ones who they have to operate well under pressure. And that's a good reminder of how we should handle, if someone cuts you off in traffic, it's maybe not as dramatic as fuel cell exploding, but how can we react to those little crises here on Earth?
Yep. Yeah, that's a really good point, actually. It's the whole demeanor of the person that it tells you if you can behave like that under those stresses. It tells you that you can probably cope with anything, including being cut off in traffic.
Absolutely. So his character was played by Tom Hanks, right?
That's correct. Yes.
That's right.
Indeed. Okay. In the movie, that's right. It's just it was, and of course it was very early in the Apollo missions. It was the third mission to land on the moon. Apollo 11, the first. Apollo 12, successful. Apollo 13 was going to be the next one, but it didn't happen. And I guess it also illuminated not just the character of the person in charge of the mission on board the spacecraft, but also the technology that was being used. NASA would have learned lessons from that about the way they handle their fuel cells and the design of the fuel cells, just as they did with the other major tragedy of the Apollo era, Apollo 1, in which 3 astronauts perished in a fire in the capsule while it was still on the ground. It was a sort of dress rehearsal. It wasn't actually a mission, and they were in the space capsule. And it was at that time that NASA used an all oxygen atmosphere within these capsules. But oxygen is very, very reactive. It'll burn with anything. And after that, they changed that so that, Apollo 1 actually led to major design changes in the Apollo missions, as I'm sure Apollo 13 did as well.
Yeah, I want to read you guys this last line of the article that was a statement from his family. He had 4 children, and his family says, "We will miss his unshakable optimism, his sense of humor, and the way he made each of us feel like we could do the impossible." I think that's a really beautiful line.
Isn't that?
Yeah. Those are the things that we want to remember when these people who are larger than life leave us is, who's going to be next? How can they inspire us to be the next, as we are in the Artemis era now, it's like, who's going to be that next person to fill those shoes?
Yes.
Let's take a break from the show now to tell you about our sponsor, Saily. If you're planning an overseas trip soon, chances are you need connectivity on your mobile device, and you can stay connected with ease using Saily. That's Saily. It's an eSIM app designed for modern travellers. With Saily, there's no need to swap physical SIM cards in your phone. Just download the app and get set up. You don't have to go looking for local Wi-Fi either. Simply download the app, choose from an affordable plan, activate your eSIM instantly. Whether you're exploring Barcelona or Berlin or Brisbane or anywhere starting with any letter of the alphabet, you are covered with Saily in just about 200 destinations worldwide. But they offer a lot more than that, not just connectivity. They have built-in security features. They have virtual location changes, makes you very hard to track. They have an ad blocker and web protection built in as well. No extra cost. And they are backed by a very solid team that works hard to protect your privacy and security. Now, this eSIM is compatible with most devices, and they offer you a seamless experience with 24-hour, 7-day-a-week support. So help is just a tap away if you find yourself in trouble. If you're ready to simplify your travel connectivity, visit saily.com/spacenuts and use the code word spacenuts for an exclusive deal. Saily is fast, it's private, it's hassle-free. Saily.com/spacenuts and use the code word spacenuts at the checkout. Now back to the show.
0G and I feel fine.
Space nuts.
And there are big shoes to fill. I mean, there's so much out there. And it looks like our next article here, if we'll roll right into that, is we're thinking we may have just discovered the biggest black hole ever.
That's right.
Is this a recent discovery?
It is, yes. So it's from an object that is known. But the research that has led to this, which has been done by British astronomers, they've analysed what we already know about this object, and it's essentially something that's very visually appealing to look at. And it's well known. It's called the cosmic horseshoe. You can find it probably on many of the websites. Because it's such a visually inspiring thing to look at. What we've got is a field of galaxies. These are distant galaxies, with one in particular that's relatively bright, what we call an elliptical galaxy, one that doesn't have structure. But around it is an almost complete circle of bluish light, and that is the image of a more distant galaxy, which is being distorted by the gravitational field of the galaxy in the foreground. So the horseshoe is actually a blurred out image of a very distant object behind the blob of light that you can see in the middle of the horseshoe, because that's the galaxy, we call it the lensing galaxy, because it is actually acting like a lens. The space around that galaxy is being distorted so that it mimics a lens that sort of magnifies and distorts the image of the galaxy behind it. And it's an almost perfect alignment where you've got a galaxy which is very distant with one directly in front of it that's much nearer. But the two are exactly aligned as seen from our vantage point in our own Milky Way galaxy. And that alignment produces this distortion of the image, which we call an Einstein ring, because they were predicted by Einstein that you would see this distorted view of galaxies. The Einstein rings were something he thought we'd never see. But we actually started seeing them in the 1970s when telescopes got sensitive enough to detect these really extraordinary structures in space. So that's what we see. That's the basic observation. But what has now emerged is detail of the structure of the nearer galaxy, the galaxy that's doing the lensing, the one that's distorting the space. It's about 5.6 billion light years from our own Milky Way galaxy. And what they've done is the scientists have analyzed basically the gravitational field around that nearer galaxy, the one 5.6 billion light years away. And in doing that, they have been able to estimate the size of the sorry, I thought I was going to sneeze there. The size of the black hole at the center of this galaxy. We think that all galaxies have a supermassive black hole at their center, if not all of them, certainly most of them. And this particular one, it indeed has a black hole. And by analyzing the shape of the cosmic horseshoe, you can measure its mass. And this, I'm just reading this in detail again. And I think what I'm saying is not, it's true, it's not the real truth of the story, which is the galaxy that is beyond, the one that is being imaged, the one whose image is being distorted by the nearer galaxy. Now, the size of that object is being estimated from all these distortions. I'm not telling this story very clearly, Heidi. I apologize for that. But the bottom line is that they believe that that the mass of the black hole at the center of this galaxy is something like 36 billion times the mass of the sun. And that will be a record. Wow. That will be a record. The one at the center of our own galaxy, Sagittarius A, star is its name, is only it's about 4 million times the mass of the sun. So this one is something like 10,000 times bigger than the one that we are seeing. Sorry, the one that we have at the center of our own galaxy. So it's really quite remarkable that you can glean this sort of information from looking at structures in space, which are remarkable in their appearance. They're quite beautiful, but tell you a lot about what's going on, the actual physical properties of what's going on out there in space. So a system of two galaxies, one of which has the record-breaking black hole at its center.
That's amazing. To be the person who discovered that would be pretty exciting. Until we find another bigger one.
Yeah, that's right. There's nothing like a record breaker, is there, for kind of attracting people's attention. It's the headline that you always want to be able to make, the biggest or the most distant or the faintest or the
mostest.
The mostest, yeah. I do remember once being able to do record a radio program about the most distant objects known at that time. This was back in 1982, believe it or not. The discovery of is actually a quasar discovered by the Anglo-Australian Telescope here in Australia. I was actually in Scotland at the time, and I recorded an interview about this object, which was the most distant object ever discovered. I listened for it on the radio the following morning, but there was no sign of it because that was the day that Argentina invaded the Falkland Islands, which was very, very big news in the UK. So all astronomical stories just got wiped. So my first radio interview ended up on the cutting room floor, thanks to geopolitical events beyond my control.
That's a bummer. Well, now look at you.
Well, there you go. Yeah. Yeah, that's right. Indeed. That's true. Thank you.
Looking at this image, it's called the horseshoe, but it almost reminds me, you nerds out there, if you guys are looking at this image, you'll appreciate this. It reminds me of the franchise Alien, of the alien embryo with the tail wrapping around when it's rolled up in the egg. That's what it looks like to me, is the alien logo. So that's a little bit kind of eerie. What if there's some kind of creature in there?
There could be. Who knows? Somebody, some creature that likes black holes.
Would that be something? Well, one thing we do know, finally, is why the rover kept getting stuck. And we have finally figured out how to unstick this poor little rover.
It's true. NASA's rovers, and the four that come to mind are Spirit and Opportunity in the early 2000s, and Curiosity, I think 2012, and Perseverance 2021. Those are what you might call the iconic rovers on the lunar surface. There are more. Tianwen-1 is the Chinese one, which I think is now defunct. I think its batteries ran out. And there were other earlier NASA ones. If I remember, Sojourner was one of the first ones. But these rovers, pretty well all of them have 6 wheels, which are sort of independently controlled. They're fitted with tires that are made of kind of springy metal with indentations in them, in order to get purchase on the sandy soil of Mars. But as you say, they do occasionally get stuck. And in fact, sometimes that getting bogged, as we would perhaps call it, is in Australian parlance anyway. You got your car bogged, did you? Yeah. Well, you got your rover bogged. That's basically sometimes led to the end of the life of some of these rovers. I think Spirit was one that got bogged, and perhaps Opportunity as well. Now, the reason why this is a bit of a pain for NASA engineers is that when they do the modeling of how a rover with the metal tires will behave in an environment where the gravity is only a third of what the Earth's gravity is, they do the modeling, and it says that they shouldn't get bogged. That they shouldn't actually have this phenomenon. They shouldn't get stuck in the soil of Mars. And so they've looked at this problem again and essentially solved it, as you've said, Heidi. What they've done is look not just at the way the lower gravity makes the rover itself behave, but the way the lower gravity makes the sand that they're trying to drive through behave. And when they use these simulations, including the lower gravitational force on the dust particles themselves, then they realize that why they're getting stuck. They're obviously going to get stuck if you do that. Basically they've used there's a number of scientists who've used a physics engine. Project Chrono it's called, and they've used that to essentially disentangle what causes this bogging, the wheels to get stuck. And that's the conclusion they've come to. If you take into account the lower gravity and its effect on the sand particles themselves, you're going to get stuck from time to time, and they do. Now, will that help the people who drive these rovers? Will it help them to get the vehicles unstuck? And the answer is probably yes. These people have for long had, I guess, tricks, you might call them. Techniques is probably a more sober word, to try and unstick stuck-up Mars rovers. Usually it's pretty well what you do here on Earth. Try and drive the thing backwards and forwards until it comes unstuck. They might be able to modify those techniques in the light of this new information that you have to take into account the lower gravity on the dust itself and not just the spacecraft.
Wow.
Sounds pretty obvious, really, doesn't it?
Fred, have you ever seen one of these like up close? Like models of them?
Yes, I have indeed. The most memorable one actually is it's in Flagstaff, Arizona, and it's actually the lunar rover. It's one of the lunar rovers that went with the Apollo astronauts. I think it was the last 4 Apollo missions, I can't remember the exact number, carried a rover to carry the astronauts around on the moon. And there's not just a replica, it was a prototype model. It's in the foyer of one of the geological science centers, I think, in Flagstaff, Arizona. And it's sitting there, and you can see how big it is, and how, just the extraordinary size of it. But and I have seen models of some of the other ones. I think Spirit and Opportunity, they're in various museums that I've had the great privilege to visit in your wonderful country, Heidi, and always take away very warm memories of those museums.
Well, that's good. Yeah, that was what I was going to say is I think the surprising thing is we don't realize the scale of these when we see images of them. And so to think something this massive is getting stuck, it's not like your little, whatever vehicle you drive. I have a little Subaru Crosstrek. It's not like your little Subaru Crosstrek gets its wheel stuck in a little ditch. It's like this is a mammoth of a machine, and for it to get stuck is a big deal.
That's right. Certainly, Curiosity and Perseverance, which are very similar. They're basically the same rover. They are big machines. Absolutely, as you say, size of a bigger car than yours, I think.
Yeah. I always think of them like little, like Wall-E the robot from the Pixar animated series. That's right. Tiny things.
Good old Wall-E. Yeah, I'd forgotten about Wall-E.
Yeah, it's a cute one.
A very cute one.
Well, Fred, those cover our stories for today. Did you have anything you wanted to add to anything that we talked about?
I did have a comment, and I forgot what it was. I was going to make another comment about the rovers. The thing that I guess, just to highlight what you've just been saying, that these are big machines. It's also the complexity of them and the ingenuity. And yes, this has reminded me of what I was going to say. Another story that's been in the headlines this week is the head of NASA, the acting head of NASA, suggesting that by 2030s, NASA will want to deploy a nuclear reactor on the moon. I don't know whether you caught that story, in order to be able to provide electrical power. It's like a 100 kilowatt nuclear reactor they're talking about. And the reason why I was thinking about that in the context of rovers is that Curiosity and Perseverance both carry effectively nuclear reactors. They're not reactors in the same sense, and they're only delivering 100 watts rather than 100 kilowatts, but they're called radioisotope thermoelectric generators. They are carried on board both Spirit and Opportunity and a number of other spacecraft like the Voyagers. They have them on board as well to generate the power that they need. So the idea of nuclear processes in space to power missions is not a new one. It's just that the idea of a 100 kilowatt nuclear reactor on the moon is a little bit bigger than some of the other ones. That was the additional comment I was going to make.
Well, that's just so valuable to just think of the size and scale and power of these. Because I think, we get the little memes of it singing happy birthday to itself. Yes. And again, we think of them as just these cute little, small, fragile little things. And they're not. They're huge, powerful, massive machines. And so the fact that we're now learning how to, improve on how we're handling them on this soil is really fun and exciting. there's always breakthroughs every week. Every week there's new breakthroughs. There's new things we discover and learn and do and see. And such an exciting time to be a part of the space industry.
Is it not? That's right. Absolutely.
Well, Fred, this has been wonderful chatting with you today. Thank you so much. And for all of you who have been missing Andrew, he is still enjoying his world cruise. I forgot to mention Andrew at the beginning of the episode. If you're new here, Andrew is normally our host, and he's been on a world cruise lately, but he will be back in a few weeks. So you guys only have me for a few short weeks left. So send in, our next episode will be a Q&A episode. So keep sending in your Q&As to us and we'll answer those. And you'll only have me for a few more weeks before Andrew's back.
It's been fabulous, actually. Heidi, just my comment on that. It's been wonderful. You've risen to the challenge of duplicating Andrew Dunkley in ways that even Andrew Dunkley can't achieve. There you go.
Oh, well, thank you so much. All right, everybody. Well, we are looking forward to catching you with our next episode, which will be a Q&A episode. Till then, we'll talk to you later.
Hi, Heidi. Hi, Fred. Hi, Hugh in the studio. It's Andrew on the Crown Princess as we get to the latter stages of our world cruise. And since I spoke to you last, we have been right up to the very top of Norway. We made our first stop in Bergen, and that is just a wonderful sail in through the fjords, under the big bridges, right into Bergen. And what we did was a little day trip out into the country where we visited some amazing sites, waterfalls, a little shopping, or not a shopping village, a little fishing village type of place, and just had a really good look around the fjords and the waterfalls and the landscape. Just a beautiful country. Of course, Norway is a very forward-thinking country, a very liberal attitude towards a lot of things, and they generate 98% of their electricity through hydro power. Quite amazing. The downside of Norway is it doesn't have a lot of usable land because it's so mountainous. And if it's not mountains, it's water because of the fjords. And so they don't have much land to live on, let alone use for things like agriculture. So they're kind of trapped in that regard. After that, we went to another place in Norway where Skjolden, I think it's pronounced. And we went and looked at a glacier, the biggest glacier in Europe. We couldn't get too close to it, but just a spectacle to behold, getting that close to one and being able to photograph it. And you could feel the wind coming off it. It was a warm day, but when you get to the glacier, it just blows this chill wind off the mountains, and you can really feel the difference. And the water coming off that glacier as it melts, and it's melting a lot faster than it ever has before, is a beautiful aqua blue as it flows down into the fjord. And then we went to Honningsvåg, and that's right up north, and took a look around Nordkapp, otherwise known as North Cape, on the 71st parallel, right inside the Arctic Circle. And they used to think it was the end of the world because, well, there is practically nothing north of that except for a few islands and then the ice cap. And the 24-hour daylight is something to behold. I went up on the deck at midnight to have a look one night, and it was daytime. The sun had set. We've reached a point in the year where the sun does set for 2 hours, but it doesn't get dark. So no northern lights. After that trip or visit, we started heading southwest, and we're heading towards Iceland. So that's our next stop, which is due to happen tomorrow, our time. By the time you get this, we'll have done it already. We'll be visiting Reykjavik and Esavajor, which is not how you pronounce it. I said North Cape. I mentioned all that. Weren't you listening? My wife's come in to remind me to tell you we went to North Cape.
I didn't hear you say Hollingsworth.
Can 25,000 of you email her and tell her I actually did it? I got a look. No, yeah, we did that, Jude. I've done all that. So should I do it again? No, I won't. But looking forward to the rest of our trip. Only a couple of more stops, as I said, Iceland, Greenland, Halifax, and then we're getting off in New York, which is not that far away now. All right, that's about it. Hope all is... Oh, that's the thing I forgot to mention. I've met a Space Nuts listener on board. Oddly enough, we met in a toilet. That happens on cruise ships because you need to go there a lot. But yeah, it was nice to catch up. My name escapes you. I tried to look up the message when you told me you were getting on at Dover, and I couldn't find it. So my apologies. I know you're listening, but it was great to run into you. If you run into us again, please, let's have another chat. But yeah, at least one Space Nuts listener on board the Crown Princess. That's it for now. Take care. Talk to you soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.